All right, now we're going to talk about inequalities. So when we talked about equalities, that was when things were the same. Well, if things aren't the same, then one of them is going to be bigger than the other. That's where inequalities come in. And with inequalities, there is likely going to be more than one answer. So let's look at an example. We're talking about all real numbers less than or equal to -3. Obviously, that's going to be a group of numbers. Okay, we'll use X to represent that group of numbers. Less than or equal to, you can see that symbol there, the number -3. So, relatively simple example. Now, let's look at something that's a slight variation on that can be a little confusing at times. So now we're going to say 7 less than a number is greater than 5. Now that's 7 less than a number. Let's say that number was 10. Let's just plug that in, right? So if we said 7 less than 10, well, we know that's 3. That's 10 minus 7. But we don't know that it's 10. So now we'll replace it. X minus 7 is greater than, throw in that greater than symbol, 5. And this is where it can be a little difficult to interpret at times because they're very similar. So plugging in a number is a nice little strategy to help us out with that. Now, when we're talking about inequalities, we have to test values, and we're going to use substitution to do that. So inequality is really easy. If we say that, for example, x is equal to 14, okay, and then we have some sort of expression, x minus 7 is equal to 3, we just plug it in, and if the things are not equal, then we know that the statement is false, okay? But when we're talking about an inequality, we're not looking for them to be equal. We're just looking for them to satisfy a more broad relationship. Okay? Do things have to be equal? That's exact. Unequal, there's a lot of answers. So let's say we want to see if x equals 3 is a solution to x minus 7 is greater than -9. We're going to substitute it in. And then once we get in there, well, we have -4 is greater than -9. That is true, but if you're ever not sure, because those negative numbers can be a little confusing, plot it on a number line. If a number is to the right of another number, then it's bigger. Okay, -4 is to the right of -9. That means -4 is greater than -9. Let's talk about how to graph inequalities. So x equals 5, that's easy to graph, right? We just put a dot there. Inequalities are going to be somewhat similar. So let's say we have less than. Remember, less is to the left. So if we have a is less than 5, well, then we're going to go to 5, but we are going to use an open circle because a can't be equal to 5. That's not part of this statement. And then we draw an arrow to the left since it's less than. Now, if b is less than or equal to 5, we use the closed circle because we want 5 to be part of the solution set. It works in this case because it's less than or equal to. And then we go to the left. Now, talking about greater than, if we have c is greater than -2, okay, well, we're going to put that open circle at -2 since it's not part of the solution set. And then we're going to put an arrow to the right. Okay. Lastly, d is greater than or equal to 105. We're going to put that closed circle at 105 since it can be equal to 105. And then since it's greater than, we go to the right. Now, all of those values where we put an open or a closed circle, okay, are our critical values. Okay? And what that means is they are an important point, even if it's not part of the solution set. So it's the start of the solutions, even if, for example, in the less than or greater than graphs, it is not actually part of the solution.